Hey there, this is just a quick video for the folks who are having a tough time with accuracy and precision. Um, as you can see, this is not a very professional looking video. I'm here in my basement because my dogs were not cooperating upstairs. So here we are. Now, as an example, I want you to imagine that you have to weigh yourself. So you need to weigh yourself on a bathroom digital scale, one of the scales where you stand on it and it actually flashes a number at you, right? Okay, so let's say hypothetically you stand on that scale and it says 155.0 pounds. Okay. Now you can just go with that number and say, all right, that's what I weigh. But how do you know it's true? How do you know if it's accurate? And how do you know if it's precise? In other words, if I want to know if it's accurate, I want to know how close that is to my actual weight. And the only real way to determine that would be to compare that measurement with the measurement of a better device. Now, what about precision? So precision is a measure of how repeatable a measurement is. Now, we can measure the repeatability by simply standing on the scale multiple times and taking multiple measurements. Ideally, every time you stand on that scale, it's going to say 155.0 pounds. But here's the thing, it won't. Okay, it's going to be a little bit higher for the next measurement, maybe a little higher than that, and then a little bit below 155. And what you're going to wind up with is a whole bunch of different values that are clustered around a central value. That central value representing what the actual weight should be. So how do we do this? Well, we go and we take a bunch of measurements. Ideally, we would take infinite measurements. It's a little bit time consuming, so we settle on 30, and it turns out that that works out pretty well. But at the end of the experiment, what you're going to wind up with is a whole list of data points. So 155.0, 155.5, 155.2, and up and down the range there. You're going to get some values above 155, some below 155. Now, if the scale that you're working with is precise, then you would expect to see a very narrow range, okay, of values that it can possibly take on. And what you'll find is that, you're going to have a lot of measurements that represent the average value, and then a certain number of them above and below. Okay, it's going to form kind of like a bell curve, where the top of that curve represents the average value. Okay, the wider that bell curve is, well, the less precise the measurements are going to be. The narrower it is, the more precise. Okay, so you get on that scale, and every time you take a measurement, let's say it's 155.0 and 154.9, 155.1, 155.0, very clustered, then we would say that that is a precise measurement. But if you get on there and it's 155 pounds the first time, and then 175 pounds the second time, and 130 pounds the third time, well, that's a very wide range, okay? And therefore, that is not a precise experiment. So, as for the question you're being asked in the homework, there are several different pieces of data being reported, and they're being reported in different ways. Okay, so let's say I have a scale that's really precise. One way that I can show that is by showing how narrow that distribution of measurements is. So if you think about it, you could say, okay, when I stood on the scale, the weight was 155.0 pounds plus or minus 1 pound, telling us that, well, I can be pretty darn sure every time I stand on the scale, the measurement is going to be between 154 and 156. Okay, a nice narrow range. However, you might have a much wider range, and in that case, it might be 155 pounds plus or minus 15 pounds. That's a much less precise measurement. Okay, so you can say plus or minus actual values, so 155 plus or minus 1 pound. Or you could say like 155 plus or minus 30%, okay, or 10%. And what that means, let's say it's 155 plus or minus 10%. Well, you take 155, take 10% of that, which is 15.5, okay, which means that that distribution is going to be 155 plus 15.5 and 155 minus 15.5. Okay, so you can actually look at that and compare that to another measurement to see whether or not that distribution is wider or narrower. Narrower is precise, more precise. Wider is going to be less precise. Now, in terms of whether or not your data is accurate, well, we always expect that there's going to be a certain distribution. There's going to be, you're not going to get the same answer every single time. But all the data, like I said, is going to be clustered around this average value. So that's that first number that we were reporting. When I said 155 pounds plus or minus 1 pound, that average value was 155 pounds. So in terms of figuring out whether or not your measurement is accurate, well, then you have to see how correct it is. So maybe you go to the doctor and you stand on the doctor scale, and the doctor scale says that you're actually 175 pounds. Well, that means that your measurements were not accurate. Okay. Now, if you get on the doctor's scale and it's 157 pounds, okay, or 150 pounds, okay, so in that case, you're a lot more accurate. So the two things you're going to be looking at, accuracy and precision. Accuracy tells you about how correct your number is, okay, and that's indicated by the first number of the data point. So the 155. The second thing that you're going to look at is precision, and precision is the measure of repeatability. And if it's repeatable, then you're going to have a very narrow range of numbers. So plus minus 0.1 or plus minus 0.2 would be much more precise than plus minus 0.8 or plus minus 10. Okay? So those are the factors you want to look at, and hopefully this clears it up for you a little bit. If it doesn't, please don't hesitate to shoot me an email. All right? Have a good evening.